Well, hello, everybody. We're at 7 o'clock. We may get a few more folks wandering in, but we'll keep them to the edges. Whoops, sorry, Julia. Welcome to the Gulf of Maine Research Institute. I see a lot of familiar faces. I see some new faces, but it's really wonderful to have everybody here. For those of you who don't know us, we're a marine research lab. We do a lot of research on the Gulf of Maine, the ecosystem of the Gulf of Maine. We have an education program. You're sitting in our beautiful facility where we bring about 80% of the 5th or 6th graders of the whole state of Maine down here to learn about science and get engaged in science and get excited about that. And my name is Jonathan Labrie, and I run our community program where we interact and work with fishing communities around the Gulf of Maine on issues that they're confronting as the ocean changes, as market changes, as management and regulatory processes change. And we're doing quite a bit of work around the Gulf of Maine and here in the state of Maine as well. Before I forget, I want to make sure that we thank our sponsor. The Morton Kelly Charitable Trust has generously donated money that allows us to run this Sea State Lecture Series twice every year and invite speakers from around the region, around the country. And it's a really great opportunity that we have that we wouldn't otherwise have to be able to bring folks in, pay for some of their travel and some of their expenses, and open up this wonderful world to you and those of us who can come and enjoy these lectures. I think everybody knows, but in case you need to know, the restrooms are around the corner that way. I just wanted to, before I introduce our speaker, I just wanted a couple of housekeeping items. Last month's lecture was canceled. For those of you who are planning to come to that lecture because of one of the many snowstorms we had, that's going to be happening next week, a week from today, so next Thursday. And appropriately, it's about tidal power. In fact, this is probably a better arrangement of the lectures anyway, to learn all about tide and then learn about tidal power in the next go around. And then I also want to remind folks later in April, on April 27th, we're having I think it's our 3rd annual seafood celebration. And for those of you who haven't come to this yet, it's a really wonderful evening. We have 5 or 6 chefs from prominent restaurants in the area working, serving seafood. We focused on these underutilized species, these species that maybe you've heard of, maybe you haven't. And you get to experience how some of our top regional chefs are thinking about seafood and serving seafood. And we have other kind of activities during the day. Those tickets are now on sale. It's a really fun evening. It happens on all floors of the building, and it's a fun way to participate in some of the sustainable seafood work that we're doing here at GMRI. I probably should cover other things, but I'm not going to do that. Instead, I'm going to introduce our speaker, and it's really exciting. I got an advanced copy of his book, and I have to admit I didn't read it cover to cover, but I read a lot of it, and it's really wonderful. I mean, I'm sure most of us here have experienced tides firsthand, one way or the other. Sometimes to our great delight and sometimes to our consternation. It's a wonderful book, and I'm sure he's going to start talking about it tonight. But I'm really pleased to introduce Jonathan White, our speaker tonight. Jonathan's a sailor, a diver, a surfer. He's logged over 70,000 miles sailing around the Atlantic and Pacific Oceans. He grew up in California, and he attended Lewis and Clark. He founded the Resource Institute, a nonprofit, ocean-based nonprofit out in Seattle. Has a degree in writing from Vermont, and you'll see if you get a chance to read his writing how wonderful and lyrical it is. He's served on lots of conservation groups, San Juan Preservation Trust, San Juan County Marine Resources Committee. He's got a real depth and engagement in this topic. And what we're going to be hearing about tonight is his book called Tides, The Science and Spirit of the Ocean. And I just love that subtitle because it does capture a real essence of the book. He was on 207 last night, apparently. I missed it, unfortunately, and he's also been featured in the Press Herald and the Bangor Daily News. So please join me in welcoming Jonathan White.
Thank you, Jonathan. Well, it's a real pleasure to be here. This is a really impressive research organization here. I've been in and out of aquariums around the country, and maybe some of you have as well, and this rates as top-notch. And it's really wonderful to see what's happening here. So thank you, Jonathan, and the staff here, Julia, for having me. As you know, I'm touring to promote the book. And I have a publicist who's arranged over 70 events around the country. And I'm going to shoot her when I get done with this. And so I am really kind of at the beginning of that. I spent the first, say, 10 or 15 of those on the west coast around where I live. I live on Orcas Island in the San Juan Islands, which is kind of a sister area to this, very much same kind of feeling. It's a group of islands, about 180 islands that are sandwiched between the mainland and Vancouver Island, just south of the Canadian border. And I live on Orcas Island. There's only 4 of them that are ferry served. And we did a series of talks around that area to kick off the book, and now I've been in Maine since Monday, and I think we've done almost 13 events in Maine in that amount of time. So I'm going to shoot that person too. But anyway, I'm really enjoying it. It's been wonderful. And like I said, it feels like home in a lot of ways. Very, the same kind of quality, the rural quality, and coastal, of course, and friendly people, and interested people. And I think one of the interesting things about talking here tonight, and of course all through Maine, is that you all live in one of the most extraordinarily interesting tide systems in the world, and I think you know that, the Bay of Fundy, Gulf of Maine system. And I'm going to talk a little bit about the Bay of Fundy because I visited there 4 times, 4 summers in my research for this book. So it's a real pleasure to be here. Thank you for coming out. Does anybody know what this is? Yeah, it's a tidal bore. And a tidal bore is a tide that comes up a river in the form of a wave or a wall of water. And there are actually more of these than you might know, many, many more than I thought when I first started doing this research. There's about 4 or 5 up in the Bay of Fundy, but they're small. And there's a large one on the Amazon River, and another one up in Alaska, Cook Inlet, and a number of them around the UK. But this one on the Qiantang River in China is the largest in the world. It gets up to 25 feet tall. And it comes in on every tide, twice a day, and has done that for 2,500 years. It used to go up the Yangtze, in fact. And then when that mouth silted in, it switched and went up the Qiantang River. So this is just south of Shanghai, and Hangzhou is the town that's upriver of the mouth there. And this bore goes upriver about 100 miles. And the Amazon has been traced up about 500 miles up the Amazon, the tidal bore. And there are lots of stories, as you can imagine, over 2,500 years about this bore, about its origins. And of course, there's the scientific stories, and there's also mythological stories. And one of the stories I'm going to tell tonight is a mythological one from the 5th century. There was a warrior named Wu Zhizhu, and he was very charismatic and young, and the emperor was jealous of him, so he had him assassinated. And he had his body boiled and sewn into a leather patch and thrown into the river. And Wu Zhizhu came up the river every tide to avenge his death. And the emperor, to stop this, ordered his armies to shoot arrows into its belly. And he did this for quite a number of years, and finally figuring out that that wasn't going to be effective, he switched entirely and started throwing flowers at the boar and built temples all up and down the river so that they could pray to the boar. They could worship it instead of fight it. And that is still going on today. There are still pagodas up and down the river, And every fall they have a festival. It happens to be at Wu Zhizhu. By the way, Wu Zhizhu was a real warrior. And it happens to be on his birthday. And millions of people come from all over China to watch, to see the boar, and to pray to it. And during that time, the temples along the river are smoking with incense. And there's red carpet down, and people are in and out praying to the sea god and to the river itself. I went there 3 times studying this and ended up talking with a lot of different people about it, and of course scientists, as well as poets and fishermen and so forth. Here it is in full force. And this happens to be a coincident boar with a typhoon, Sinlaku, off the coast a number of years ago. And that's when it's largest, when it combines with a storm, a low pressure system. And it frequently jumps the jetties and floods the farmland and drowns people. I mean, sometimes hundreds of people are killed every year by this boar. Native people, people who live there, as well as tourists that are caught unaware. In the book, I meet a man who lost his son just months before I talked with him, and he opened up to me, and I tell the story of him losing his son. This boar, because it's been going on for 2,500 years, is the site of the first tide chart. And it was found in 1000 AD, and it's a stone tablet etched, and it actually accurately predicts the arrival of the boar at different locations along the river, even today. And the western first tide chart was for the London Bridge, and it didn't appear until about 200 years later in 1200. In my research, I kept coming across these amazing facts, and it's partly what drew me into this, just like peeling an onion, fact after fact after fact that kind of blew my mind. And I'm going to, before I go on into the body of this talk, I'm going to just mention 4 of them. And there are scores of them. But the first one is that the tide is a very large, long wave that travels around the world at the speed of a modern jet, 450 miles per hour. It has no beginning and it has no end. And what we see on the beach, if we stood there long enough, is the crest of that wave, high tide, and then roughly 6 hours later, the trough, and then 6 hours later, the crest again, high tide again. And we don't experience it as fast because it's such a long, low wave. But it's traveling at 450 miles per hour. Water wells as far inland as Texas and Wisconsin produce more water during a flood tide than during an ebb tide. For 99% of human history, we had no idea how the tides work. It wasn't until a blink of an eye ago, about 300 years ago, at the end of the scientific revolution, when folks like Newton gave us the laws of motion and planetary motion and gravity, which gave us for the very, very first time a foothold to understand the tide. And the understanding of the tide down here took a long, long time after that. So for most of human history, we had no idea how the tides worked. But even though the written record doesn't give us the information about it, I think we can be sure that the people who occupied or settled along these coasts had a very intimate and practical relationship with the tide. They understood what was going on, the relationship between the moon and the sun and the tides. I mean, they needed that for survival, right? They settled along the coast, and because that's where they could easily get food in the intertidal zone. And they saw that the full moon or the new moon had an effect on the tide and what it was. And I'm sure that over time, handing that information from generation to generation, they accumulated a lot of information, practical information about the tide. They probably even noticed that there were times when the moon was full and looked bigger than at other times. And we know today, of course, that the moon doesn't circle the Earth in a perfect circle, but that sometimes it's closer to the Earth in perigee, and sometimes it's further away from the Earth in epigee. So when we have what they call king tides, it's usually because we have a full moon or a new moon in perigee, closest to the Earth. But I'm sure that they knew that. They might not have had the terms for it, but they knew that a large moon meant a very large tide, meaning a large high and a large low or a low low. So they could get access to things in the intertidal zone that they couldn't otherwise. But I think we could also be certain that they wondered about what was going on. Like on a moment where they've got their clams for the day and they're making a fire on the beach and the full moon comes up, I'm sure that they wondered, well, how does the moon do it? How does she reach out silently and invisibly over all that distance and stir the waters of the Earth? They had no idea. But there was a lot of speculation. Some people thought that the moon did it by heating rocks on the bottom of the ocean. And those rocks heated the water and the ocean swelled, and that was high tide. And then when the moon went away, the rocks cooled, and that was low tide. Astrologers were convinced it was divine power. And they cited tides and women's menstrual cycles as proof of the moon's influence on Earth and the fate of people. And some people thought it was a great beast. The Chinese thought that the tides happened when a dragon went in and out of its cave. That was high tide and low tide. And Leonardo da Vinci was convinced it was the breathing of a very large beast. And he tried to calculate the size of its lung. Where I live, just north of where I live, Haida Gwaii, high tide woman made high tide by lifting her skirt. And we know that's not quite the way it works today. So my interest in this subject comes really just from a love of the ocean, probably like all of you. I grew up on the coast down in Southern California, surfing and diving and sailing, kayaking and so forth. And it seems like I always had a tide chart in my back pocket. And out of school, out of college, I went to Lewis and Clark College in Portland, the other Portland, the one that came later. I built a little boat, a 26-foot boat, and I sailed it on the Pacific, Atlantic, and in the Caribbean. And then about in the early 80s, I came back up to Seattle. I sold that boat, and I was looking for a graduate program that I could get involved in. And I was kicking around a wooden boat shop like I frequently did and do. And I saw this crinkled up picture of a old wooden schooner for sale. So I got in my Volkswagen Bug and I drove down to Tillamook, Oregon, where it was. And it was way up in the flats and halfway in the mud. And it was a really wet, drizzly winter day. You know, we typically have really wet winters, you probably know, unlike you. But it's just gray and drizzly all the time. And it was that kind of day. And I went down below, and the owners had a wood stove going. It was nice and warm, and I could smell rotting wood. And the boat was painted all orange, and it leaked 150 gallons a day, and it was perfect. So I bought it, and instead of going to school, I started a nonprofit educational organization on the boat and brought in presenters, and we did seminars up and down the coast from Seattle all the way up to Southeast Alaska. And we did almost anything you can imagine for subject matter. Navigation, boat handling, natural history, Northwest Coast, Indian, art, culture, mythology, poetry writing, psychology, music. We had a seminar called Hook, Line, and Singer. So we did a lot of different things. We had Paul Winter on board, and we played music while we were floating up in Glacier Bay. We had writers like Peter Matheson and Gary Snyder and Allen Ginsberg and Gretel Ehrlich and William Stafford on board, and scientists like Lynn Margulis, who co-founded the Gaia hypothesis with James Lovelock. and Roger Payne, who's attributed to having discovered the songs of the humpback whales. So a lot of different presenters. And my first book came out of those experiences. It was a collection of interviews about nature with those people. It was published by Sierra Club Books in the mid-90s. We had a lot of, I'm going to show you that boat. That's the boat there. We had a lot of fun in those 11 years up and down the coast. We figured we logged 50, 60,000 miles on that coast, up around southeast Alaska, around Haida Gwaii, around Vancouver Island. But one not so fun experience was going aground in a large tide in Alaska. And we were on a seminar coming back from the outer coast of Chichikov Island and on our way into Sitka. It was the last day of the seminar. And the next morning we had planned to take a walk around Kruzof Island where we were and then motor into Sitka to end the seminar. But there was a prediction of a gale that night, so I made sure we were in a really good anchorage. And about 3 o'clock in that morning, I woke up and I was relieving myself off the stern. And I noticed that something wasn't right. And as probably most of you know, when you walk on a boat that's floating, there's a hollow, soft, resonant feeling. It's a little hard to describe, but when that feeling isn't there, it's really distinctive. And it's almost like walking on concrete. I'm sure none of you have had that experience. I've had it a lot, so I know the feeling very, very well. So in that morning, I'm alone out there, and I got 12 passengers, paying passengers on board. And I'm thinking to myself, okay, I've been here before. If the tide is low and coming up, no harm, right? The boat's just going to float up. Nobody'd even notice. It'd be up and floating before breakfast. But if the tide was high, it could be disastrous. So I went into the pilot house and I grabbed the tide chart and I started flipping through it and I read it, 5, 6, I don't know how many times. I couldn't believe it. We were at the top of the high. The top of the high, and in the next 6 hours, the tide was going to go out 12 feet. So Crusader draws 7 feet, and we're already on the ground. So I knew that not only would we go all the way down on our chines, but most of the water would disappear out of this bay. There would just be a puddle of deep water where we should have been. So we had dragged anchor through the morning, through the night with the gale, and we're aground on the end of the bay. So I woke up the crew and everybody else. It's still blowing a gale. It's 3 o'clock in the morning. It's dark. And we got everybody on shore. And there was grizzly bear sign everywhere on the beach. So we had somebody stand by with a rifle. And a few of us stayed behind to do what we could to salvage the valuables on the boat and to make sure everything was okay as she went down. And indeed, what happened is we went all the way down on our chines, on our side, and got stuck in the mud. So when the tide came back in, the boat didn't want to float. She stayed and just filled with water. And I remember the engine, a big old Detroit diesel, which I was very proud of because I'm not a mechanic, but I ended up having to rebuild this engine. And after I finished, it's about 5 feet tall and about 7 feet long, big engine. And I was so proud of it. I had painted it all red at the end of rebuilding her. And I watched as the tide lapped at the bottom of the oil pan. And I thought, okay, I've got fresh oil. I can imagine I can pull off the pan, clean it out, and put fresh oil in. No harm. Well, then I watched the water rise up above the batteries, and then above the injectors, then the valve covers, and then the red diesel disappeared in the tide. And the same thing happened throughout the boat for all the things. And we were swimming through the boat towards mid-morning. And all our provisions, 7 months worth of provisions and all kinds of different things, were up and afloat. A lot of the things that could, like pasta, swollen out of its bag and was floating through the cabins, and fruit, bananas and oranges and plum, floating through. And as the morning wore on, and we were hungry and moving around, people would grab the fruit and eat into it and then set it free again. So there's all this half-eaten fruit floating around. And we had a lot of books on board, over 300 of them. And they swell, if you've ever seen it, 3 times their size. And they're actually formidable weapons when they swell like that. And they're floating through the cabins and the boat too. And I mean, we couldn't help. There were some pretty funny titles that floated by that day, like Ed Ricketts' Between Pacific Tides, or Ram Dass, How Can I Help? And then, or Robert Bly's When Sleepers Awake. And one of the crew at one point lifted up this big soaked copy of Maxine Kumin's In Deep. We did get Crusader. This is mid-morning, and the Coast Guard came by and dropped off 3 pumps. That really was the thing that saved us in the end, because we were able to get enough water out of the boat that she finally just released from the mud because of buoyancy. And there were 3 other distress calls going on up down the coast, so the Coast Guard just dropped these off and said, "You're on your own. This is the best we can do. We got to go take care of these other boats." So she did come up. The participants that were on the seminar had gone back to Sitka on a fish boat, and 3 of the crew and myself stayed there all night and really cleared out the engine with fresh water and motored back into Sitka the next morning. And the boat went out on the next seminar 3 days later. Yeah. We had almost 30 people working around the clock for those 3 days and shipping things up from Seattle, new electrical systems and parts and so forth. So I got the tide out of Crusader, but I couldn't get it out of my head. And so I thought, okay, probably like a lot of us, I thought, I'd like to learn about the tide. I know the moon has something to do with it, but I'm not sure what exactly. So I thought, okay, I'll take a couple of weeks and read a few books, and I'll learn what there is to know about it. But the more I studied it, the more I read, the more fascinating and complex and mysterious and poetic it was. So a couple of books quickly turned into 10, and then 30, and then 300, and a couple of weeks quickly turned into 10 years. I wrote an article for Orion magazine in the mid-90s about the tides on our coast, the BC coast. And they have very, very strong currents there. That's what's extraordinary about that coast. And I also got a contract with Natural History magazine and went to write about the Qiantang River, the tidal bore on the Qiantang River. And then about 7 years ago, I committed to writing this book. And there are many themes about the book, but basically it's a journey, as you can see, of a guy that is curious and wants to know what's going on with this. And I just kept going. It got more and more interesting as I went. It really could be a lifetime study. And I'm not a kind of obsessive person. I've never really even studied anything for that long, for 10 years. As my wife says, it's like you went down a rabbit hole and you haven't even come out yet. So it's really, I've just found that it's just incredibly fascinating. And the more I talked to people and the more I traveled, the more I learned how it was fascinating for people, for other people as well. Basically what I did is I followed the tide. So I took some element of how the tides work, like a tidal bore, the large tide, or resonance, or large currents, or tide energy, and so forth. And I went to where that was most dramatically at play in the world. So for a chapter on tide energy, and I know you're going to get a talk in a week or so on that, which will be interesting, I went up to the north tip of Scotland, the Orkney Islands, where they're doing the most work on tide energy right now. There's, as you probably know, there's a group up in Minas Basin called FORCE, and that's a site where people can test devices. And this is a similar site, it's just larger. And Scotland has a political situation that is really supportive of this kind of thing. And then for the same chapter, on the other end of the scale, I went down to the south end of Chile, the Straits of Magellan, where they have tremendous tide resources, but they don't have any devices in the water. They want to, but they just aren't far enough yet. And then for a chapter on culture and spiritual history of tides, where I talk about very, very early history of thinking about the tides, I went to Mont Saint-Michel in France on the Normandy coast, the west side, all the way on that coast, and it has a tide of about 45 feet. And this sandy area, there's a lot of quicksand there, and when the tide is out, not unlike some places here, it's completely disappeared. And in this case, it's about 10 miles away. And when the tide comes in, you can see this molten silver thread on the horizon. And then within minutes, it's coming across the sand like galloping horses. That's the legend, and indeed, that's how fast it comes in. So about 3 or 4 tides a year are large enough to actually top this causeway. And this was built in the 7th century and occupied by Benedictine monks for most of the years. It was a prison for a short while, but even today it's occupied by monks and sisters. And I went there the first time and wanted to interview them, but I didn't get permission. And I worked with a guide and a translator for about 2 years, and I finally got permission from them to come back and have a silent lunch and a 30-minute interview, which turned into an hour. But I got to pick my time, so I picked the largest tide of the year, and I had this wonderful experience with the monks and sisters there. And I write about that in that chapter. It's kind of the theme story for there. And then for a chapter that I call Ancient and Future Tides, that takes the larger geological arc of tides and includes a discussion about sea level rise, I also went to 2 places. The San Blas Islands off the east side of Panama, which is an island chain of about 350 islands. This is one of them. And it's occupied by indigenous people called the Cunayala. And they have 2 interesting kind of paradoxical beliefs about the tide. One is the traditional belief that the tide is a spiritual visitor from another dimension, come to check up on the village. So when the tide comes in, and if it decides that everything is okay in the village, it goes away. And if not, it stays. So that's a view, of course, about sea level rise. And some of the elders believe that that is actually what's happening. That as sea level rises, it's that spirit that's not happy with them. There's also, among those same people, they have scientists who are studying the tides and inform them that if sea level rises 3 feet in the next 50 years, which is a conservative estimate, they will lose all their islands and they have to find another home. So they live with both those views, and they are making plans to leave the islands. But as you can see, they live like at 3 feet above sea level maximum. And on the other end of that spectrum, I went to Venice, Italy. And as most of you know, this city was founded in the 7th century, and it has been dealing with tide issues ever since it was founded. So it's always flooded. It's always been low. And then in recent years, groundwater extraction has caused the land to sink and has exacerbated that tide problem. They no longer do that, but the land is still sinking. And this is San Marco Square. All the hotels give out rubber boots. And these wooden platforms are called passerellas, and they stay all the way through the city stacked. And then when they know it's going to be a large tide and there's flooding, and it's almost 60 or 70 times a year now, the public works people come out and spread them out so people can walk. And it's mostly the tourists that walk on those. The Venetians are so accustomed to this that they live with it the way I live with the rain in the Northwest. You know, it's just a fact of life. The tides come and go. It's announced on the radio. There are sirens that tell them. So tides are in their consciousness all the time. And in fact, they plan their routes. You know, there's no cars in the city. It's a walking city. So they plan their routes according to the tides. Like in Seattle, you would plan your routes during rush hour to avoid certain streets, right? So they avoid the lowest parts of the city. They know exactly how high their rubber boots are, and they know exactly the elevation of that street or that street, and they avoid it if the tide is too high. There's a bookstore there called Aqua Alta, and it's located at the lowest part of the city. And it's a small bookstore, maybe the size of this area here, and it's loaded with books. I mean, just stacks and stacks of books. And it's all raised above the ground. And it's in bathtubs and kayaks and gondolas. And the owner stays open all the time, and it floods regularly. And people come in, and all he asks is that they not splash. So they're waiting around carefully and looking at the books. And there, we're so used to the tide coming and going on the coast. But there, the tide bubbles up through holes in the cobble. It comes through the stormwater. It's really wild. And I sat there and watched during a whole cycle, and the first little bubble come up through the stormwater, and a little bit of lettuce came up, and a cigarette butt, you know. It's a little bit silty. And the Venetians often don't complain so much about the water, but they complain about the silt. And then for the largest tides, here, the Bay of Fundy, which has a record of 54.6 feet. And north of here, about 1,200 miles, Ungava Bay, because it has a competing tide. And some of you may know that about 10, 12 years ago, the Inuit people who live up here contested the record that the Bay of Fundy had. Because in the Guinness Book of World Records, it lists the Bay of Fundy as having the largest tides in the world. So they said, we think that we might have at least an equal tide, maybe larger. So it started this whole strange competition where they hired scientists to test and so forth, and they went on. And NOAA finally declared it a tie. Basically, they said, well, okay, on Monday and Wednesday and Friday, it's highest in Ungava Bay, and on Thursday and Saturday, it's highest in the Bay of Fundy. So now the Guinness Book of World Records lists them both. And I went up there. I went up there one summer first, and then I went during the wintertime. And I'm going to read a little section from the book about my experience up there. Oops. It is well below zero, and a light snow is falling as I watch Lucas C. Knobloch prepare his snowmobile for hunting. He harnesses a plywood sled called a caliga to his machine and stows a shovel, rifle, can of gas, drinking water, and a torque, a long steel rod sharpened on one end for chopping ice. When the gear is stowed, I swing my leg over the stern of the snowmobile and settle onto the passenger seat. We are ready to leave his village, Kangasuiak, one of 14 Inuit settlements that cling to the coast of Ungava Bay in northern Quebec, Canada, 200 miles south of the Arctic Circle. No roads connect the villages, nor the villages to the cities of Quebec and Montreal, 1,000 miles south. Within seconds, we drop onto the frozen surface of Wakem Bay, a 2.5 mile wide slab of ice that heaves up and down with the tide, leaving its edges strewn with automobile-sized ice blocks. We follow a well-worn snowmobile track which quickly splits in 3 directions. On late winter days like this, Lucas and other hunters from his village might follow the track leading inland, hunting for Arctic hare and ptarmigan. They might follow the track leading west, looking for seal and walrus. Or, during extreme low tides of new and full moon, they might follow the track we have chosen, which leads north 4 or 5 miles toward the bay's opening into Hudson Strait. If conditions are just right, hunters on this track will use their torque to chop a hole in the 3-foot thick ice, and while the tide is out, shimmy into the hollow regions below the frozen bay to forage for blue mussels. I had met Lucasy several years ago and was intrigued by his invitation to join him under the ice. But it had taken 2 winters before he was confident that the ice and tide conditions were just right. Lucasy drives a snowmobile slowly and cautiously over Wakem Bay. But even so, the wind chill, minus 15 degrees Fahrenheit, numbs my face and extremities. We skirt the edge of the bay, slowing several times as Lucasy studies the piled up ice and snow marking the intertidal zone. In winter, thick layers of ice accumulate. Anchored on one edge to the shore, the ice floats as the tide comes in, but when the tide goes out, it's left awkwardly aground. Under these rifted and crumpled slabs, cavities form, and they go dry when the tide is out, offering a chance for experienced hunters to gather fresh protein when summer stores are low and wild game is scarce above ground. Lucasy stops and turns the engine off, asking me to wait while he pokes around. No, he says, returning not right. Several minutes later, we stop again. This time he comes back with a hint of excitement on his usually stolid face. We gather the shovel and torque and hike over a bank of buckled ice, stopping at a long, steepled fracture. Lucasy squats for a closer look at the jagged opening. Satisfied, he removes his jacket and chisels at the fracture for half an hour until he breaks through the 3-foot thick ice, shaping a hole about 20 inches in diameter. He wastes no time, no strokes. The window of opportunity opens a couple hours before low tide and snaps shut 4 hours later. This is a window no one wants to miscalculate. Stabbing the torque into the ice so it stands on its own, Lucasy again asks me to wait while he inspects the cavity. His caution, like that of any good hunter, is reasonable, but I am not at all prepared for the feeling of being left suddenly alone while my guide vanishes down a dark hole. I take in hesitantly just how alone I am and just how vast and beautiful and deadly the landscape is. The bay's surface appears quiet and still, but in fact the tide keeps it in constant motion, breaking the silence now and then with ghostly moans and jolting explosions like gunshot as the ice adjusts to the ever-changing conditions below. Before I can think about this too much, Lucasy's head bobs back up through the hole. It's good, he says, lots of mussels and room to forage. He has carved a small foothold in the opening, but the diameter of the hole is too small to allow my knees to bend. After struggling a bit, I realize the only way down is to straighten out and slide. So I do. I let go and drop, landing 6 or 7 feet below the surface in a pile of ice and rock and seaweed. For several minutes, I am completely disoriented by this instant plunge from the bright, frigid upper world into a dark, warm underworld. My glasses and camera fog instantly. The air is close to sea temperature, 40 degrees Fahrenheit, nearly 60 degrees warmer than 7 feet above my head. As my eyes adapt to the dimness, I notice that the tent-like cavity has a 5-foot-high center ridge that parallels the shoreline. The sides taper out, leaving a foraging area of about 20 feet wide by 100 feet long. The seafloor drops in places, allowing enough headroom for me to stand upright. Muted blue light penetrates from above where the ice is thin or fractured. Bits of seaweed and detritus cling randomly to the ceiling, evidence of the last high tide. A crab skitters across the rock and disappears under the seaweed. As I adjust to the eerie surroundings, my breath shallow and quick, I feel like I have dropped into an entirely unknown and unexpected realm, as if the tiny hole carved by Lucasy allowed us to slip mysteriously not just under the ice, but under the surface of the sea. Here, in a dreamlike state, I feel inside the body of the ocean. I did get out. So I know that there's a ferry, and I'd like to close in time to have some questions. So I have a film about resonance. And to introduce this, it's a 6-minute film. And to introduce this, I just want to say that the tides are a lot of things. And one of the challenging things for me in researching this is the paradox sometimes of holding all those things in my head at once. Like, if it's this, then it can't be that. And if it's that, it can't be that. But in fact, there's a lot of ways of looking at the tide. And it's all accurate. It's all true. But it's challenging at times. But if you boil this all the way down, it's really about vibration. And even more so, it's about resonance, which is when something vibrates in response to something else. So we know resonance, for example, with a bell, and you hit the bell, and the bell resonates. Or a common experience that we all have is singing in the shower. And I know you all do that. So when you sing in the shower and you hit that particular note that resonates with the shower, or that the shower resonates with that note, all of a sudden that note comes alive, right? It's amplified, it's exaggerated, it sounds really good. You think maybe you picked the wrong occupation. You feel like a genius. Well, that's the shower stall resonating with your voice. And if you blow that analogy up into the size of the solar system, that is really the way tides work. That's why we have a really large tide in the Bay of Fundy, because it's highly resonant. So if you blow that up, the voice, your voice, messing around in the shower, is any one of hundreds of relationships in the sky between the Earth, Moon, and Sun. And there's over 400 of these. And on Earth, the shower stalls are the ocean basins of the world that might resonate with this note or that note, but not that one. So I'm going to show this film and then make some concluding remarks, and then if you have questions, I'd be happy to try to answer them. When I was researching my book, I was surprised to learn that music can teach us a lot about how the tides work. I know it sounds a little far-fetched, but think about it. When you pluck the string of a guitar, the body of the guitar resonates. This also happens in the shower stall when you sing and you hit that note that suddenly sounds deep and rich. That's the shower stall resonating with your voice. The tides work the same way, although in this case, the musical notes are the gravitational pulses from the sun and moon, and the resonating body are the ocean basins of the Earth. We think of gravity as a constant, and it is, but its strength varies depending on where the sun and moon are. The moon's gravitational pull, for example, is strongest when it's full, or overhead, or closest to the Earth. In the study of tides, these positions are called beats, or pulses. But for our purposes today, let's call them notes. I wanted to find a way to clearly demonstrate this, so I asked some musicians to help out. What's happening here today is we're squeezing the whole universe down into the size of this chapel. You guys are the sun and the moon, And these cans are the ocean basins of the world. Resonance is when something vibrates in response to something else. So it's very much like your instruments here and your voice. So that's what we're doing today. Those frequencies are very long, over 12, 24 hours, sometimes over 2 weeks. Your frequencies today look like this. You know, they're in seconds, right? These cans are all different shapes and sizes. Some are deep, some are wide, some are shallow. The smallest one's a sardine can. That largest one is a garbage can. It's just like the ocean basins of the earth, all different shapes and sizes. And each ocean basin responds differently to the same astronomical note. And that's why you can have a tide on one beach that's big and then travel a mile down the way and you don't have much tide. It's because that basin is resonant with some note from the moon or sun, and the next beach a mile away is not. We're going to experiment with the notes that you guys play with your instruments and how it excites or does not excite different basins right here in front of you. So in some simplified way, what you all are trying to do is get the salt to bounce. What you're seeing here is the notes of the clarinet are causing just those particular cans to resonate. And when those cans resonate, the salt moves. Let's continue going on one at a time. Can you find a way in your voice to activate these kind of one at a time separately? I think that did it. I think that did it. They're not all just going off, but it's a particular note that's hitting this one and that one and that one. Notice it makes a difference what note he plays, how loud he plays it, and how close he is to the cans or the ocean basins. Let's try the saw. Oh, there you go, the little can. Why don't you go, Dimitri? That's the first time the large can has resonated. It's responding to the low frequencies of the tuba. Nice. Everybody join in. Let's just mess around and see what happens. The results of the experiment were remarkable. We created a miniature universe, and I think we got closer to understanding how resonance shapes the tides. Thank you. Thank you. So I know some of you have to go to catch this ferry, so maybe I should take the questions now. Yes?
So, you're talking about full moon and sun and all that. But when we think about full moon, we're thinking about a moon that's fully illuminated. But when you have a half moon or a quarter moon, the entire astral body is still there. It's just not illuminated in the same way. So, what is the difference between, I mean, full moon, fine, we know a full moon because it's fully illuminated, but you know, the gravitational pull of the astral body, how different is it? Because it's
Right. So the question, everybody get the question. So why, when we have a half moon, why wouldn't we have the same influence? Because the full moon is there, right?
yeah.
So what's going on really is just that it's all about the relationship and the moving, continuously moving relationships between the Earth, the moon, and the sun. So the sun, even though it's much, much bigger than the moon, it's much, much further away. So it has half the influence on the tides that the moon does. But it has enough influence that our tides are always the result of the relationship between the Earth, moon, and sun. So when we see the full moon, the Earth, moon, and sun are aligned. And both the moon and the sun are working together. That's when we have full moon and new moon. It's an alignment. There's a Greek word called syzygy, and that's what that is. So new moon and full moon. You can imagine they're all in a line. But when the moon is at either quarter or 3/4, the moon and the sun are working against each other. So the sun is robbing some of that gravitational pull of the moon. You're absolutely right. The whole body is there, so why wouldn't there be a large tide? But it's because the sun is grabbing some of that and compromising it. Anybody else? Yes?
You had said the impetus for studying or researching the tides came from when you grounded the schooner? Is that?
Yes.
Okay. So what was your question? What were you trying to explore specifically?
Well, I knew the moon had something to do with it, but I didn't know what. And I was just curious, like, okay, it's time to learn what's going on here. That's really what it was about. Yes?
How did you get out of the hole?
I didn't. Lucy had to go and get a ladder, and there was a ladder on the Kalika. In fact, I had to change that in the book because my editor, who's here tonight over here from New York, said, you have to have a ladder on the Kalika because you got to get out of there. Yes, behind.
I'm still not clear about resonance. So, is it the resonance of the movement of the water within the given shape of the bay, the embayment? What is it that is resonating?
The ocean basins. And when we look out over the water, we generally see one large basin. I mean, we tend to think of the 7 seas of the world, but actually within each one of the oceans, there are many, many basins that you can't see the definition from the surface. And that's defined by the shape of the bottom, right? The length, the depth, the width, even the salinity and water temperature affects the way that basin vibrates. And it could be a very large basin or small ones. So each one of those has a different tendency to vibrate, what they call a natural period of oscillation.
So it's the water that's oscillating. That's
Yes,
the analogy that it is.
yes, yes, yes.
And so the character of gravity, did physics define that similarly to like a vibration, like a musical instrument? I think of it as like a pole. So is it similar to a vibration in its movement?
Yes, I know. And so the question was, you think about gravity as a constant pull. So where do you get pulse, or where do you get beats out of that? Is that what you're thinking? Yeah, and so that's one of those little bit of those paradoxes about the tide science, is that in order to understand it, and this goes way back to Newton and Halley and even Kepler. In order to understand what's going on, what they did was they froze those relationships. So a full moon and a new moon on the other side of the Earth, those are frozen relationships, and they even have their names. They're not very poetic names, but like M2, S2, S1. And again, there are over 400 of those. And so those are frozen relationships that constitute what they say like a moment or a pulse or a beat. In scientific parlance, it's a constituent. And they can actually calculate what the signature in the tide is of that relationship. So full moon, there's a signature on Earth for that full moon. And there are many of these. So when they put together the tide charts, for example, they figure, depending on where it is and how critical it is to know what the tide is doing, NOAA uses in our country about 35 of these beats or constituents to come up with our tide table. And like up in the Cook Inlet in Alaska, where it's treacherous water, a lot of tide, a lot of rocks, and a lot of shipping, they use 80 of these. In Italy, where there's not so much tide, they use 3 or 4 or 5.
One more question. Then we'll let
One more, somebody new? Yes, over there.
Would you explain or elaborate on your 450 mile an hour wave?
And is there some other particular question in there about that, or just, you want me to just talk more about it? Yeah, what's going on?
Is there a wave going around the Earth in all the oceans? I mean, what did you mean by your comment?
So earlier I said sometimes you have to accept paradox. You know, it's a little hard sometimes to wrap your head around all this. So it is true that the tide is a wave that's constantly traveling around the world. But it's not just a single wave. It actually wraps around what they call points of no tide. And they call these amphidromic systems. And there are many, many, many amphidromic systems. They look like daddy long-legged spiders, right? With a center point and these long, long waves. And the waves circle around these points of no tide. Where I live, the large amphidromic system is near Tahiti. And that wave sweeps at 450 miles an hour all the way. You can track it from mid-Mexico all the way up the coast at that speed, and then around to Asia, and then back around. Now, there are other amphidromic systems within that, but that's the major one. And I honestly don't know where the major one is here in the Atlantic. But again, there are many of them. Amphidromic comes from the Greek word to dance around. It was a child naming dance. So they danced around in a circle, they held hands, and they gave the child a name. It was called an amphidrome. So these are amphidromic systems. And the tide circles around that, and the point in the center is no tide. So it's partly why Tahiti has one tide a day, because it's really close to that amphidromic point. And if you're thinking that the tide is 2 times a day everywhere, that's not the case. I mean, there are places where there's 1 tide, there's places where there are 2, there's places where there's 4, there's places where there's 6, there's standing tides, standing low tides, standing high tides, disappearing tides. There are all kinds of tides. And what you have to do to understand it, actually, is get away from the general rule and then go specifically to that location and find out what's at work right there. Because it could be all kinds of things at work there that are not at work 2 miles down the coast. There's one more up here. Did you want to let the ferry folks? Yeah.
And then we can
Do one more.
We can do one more. But before you guys leave, let's give Jonathan.
Thank you.
Anybody needs to leave, now's a good time, but otherwise we can take a few more questions.
Well, there's one up there. Yes.
So during a lunar eclipse, when the sun and the moon are both at the on the same day, same
Plane. Yeah.
position, are they working against each other or are they working together?
No, in that case, they'd be working together because they're aligned. Yeah. There was a question over here.
Having sailed here, you've got your 2 tides a day, every 6 hours. And then sailing, can you explain why in San Juan Islands we didn't have 2 tides a day?
We what? We don't?
Yeah.
We do.
Not every day.
In the San Juan Islands, where I live?
Yeah. It's not like every 6
Oh,
hours.
okay, okay. All right, well, okay, so we're going to go back to resonance. So remember in the film, it took the tuba to move the biggest cans? So it's the lowest frequency that was able to resonate with those big cans? So not the flute, not the clarinet. It just wasn't low enough. The frequency wasn't low enough to hit those big cans. Well, that's also happening, of course, in the oceans. So the sun is the lowest frequency on a normal basis, right? Because it's a 24-hour cycle. The moon is basically a 12-hour cycle. So the largest basin in the world, the garbage can basin, is the Pacific. And what that means is the Pacific is almost as resonant with the solar cycles as it is with the lunar cycles, more than any other ocean. The Atlantic is mostly the moon. It's all oceans are influenced by both of them, but the Atlantic is mostly resonant with the moon. The Atlantic is mixed. So in fact, we have what they call mixed tides. So there are times when the Pacific is responding more to the sun and times when it's responding more to the moon. That's why we have such crazy tides there. And it's partly also why Tahiti has that one tide a day.
Okay, now really, one more, and then we'll have to break up.
Yeah.
Yeah.
Is there one more somewhere? Way back there, yes.
Well, I wondered, do people ever surf the tidal bore?
Yes.
Have you?
No.
That's a short one, so you can go.
Yeah, they surf lots of boards. You can't, the government won't let you surf the one on the Qiantang River. They did allow a surf team to go in there about 5 years ago, and they were allowed to surf one bore coming in. Yes, you one more since.
I just along the same thing. You mentioned that bore is 2,500 years old. How do they know that? And you know, why has that been going on for millennia?
For longer, you mean?
Yeah, why not 10,000 years or 100,000 years?
Well, I don't know the answer to that. And maybe it's possible it has. Like I think I said here that it used to go up the Yangtze, and then the mouth of the Yangtze filled in, and when it moved, and now it's going up the Qiantang, and those two rivers almost share a mouth.
So you can learn a lot more by buying Jonathan's book, which we
Thank
just
you.
happen to have. And I'm sure you'd be happy to sign.
I'd be happy to
You'd be
sign
happy
it.
to sign too. So thank you so much for coming. Please come again next week, and we'll see you soon.
Oh, thank you.
No, I'm Doug Welch. I run the Maine Island Trail Association here.